Okay, let's dive right in. Have you ever really stopped to think about your hand? I mean, it's not just a tool, right? It's this incredible piece of biological machinery. It can show incredible strength, but also the most delicate precision. We're going to break down exactly how it all works, joint by joint.
And hey, it's not just me saying this. As one of our sources, Dr. Serdoun, puts it, the hand is a masterpiece. And that word really sets the stage for the amazing complexity we're about to get into.
So, what's the real secret? What is it that lets you pick up a heavy box 1 second and then thread a tiny needle the next? Well, the answer is all in the brilliant design of its joints.
So, our journey is going to start right at the base of the hand, the wrist. Now, this isn't just some simple connector to your arm. Oh no, it is a dynamic, flexible foundation for everything else the hand does.
See, the wrist is actually made up of 8 small bones, called the carpal bones, and they're all connected by what we call intercarpal joints. Now, these aren't big, dramatic, bendy joints. Instead, think of them as creating these really subtle, gliding movements between the bones. And it's that teamwork, all of them moving together, that gives the wrist its amazing range of motion. So how exactly do they glide? Well, they're a special type of joint called a plane synovial joint. The easiest way to picture this is to just imagine two flat, smooth, wet surfaces sliding past each other. That's basically what's happening between all these tiny bones, and that's what allows the wrist to adapt and move so fluidly.
Okay, so let's move up from the wrist and into the palm of the hand. This is the crucial bridge, the part that connects that flexible foundation we just talked about to the fingers. And this connection is made by the carpometacarpal joints, or CMC joints for short. This is literally where the carpal bones of the wrist meet the long metacarpal bones that make up the structure of your palm. And this is where the design gets really clever. Check this out. The CMC joints for your index and middle fingers, they're almost completely immobile. They don't move. This creates this solid, stable axis for the whole hand. But the joints for your ring and pinky fingers have a little bit of give, a little bit of movement. And that slight mobility is what lets you cup your hand or grip a ball. So you get both stability and adaptability built right into the design. Pretty cool, huh? All right, now for the parts that do most of the visible work, the fingers. These are our precision tools, and their joints are engineered for some very specific, very important movements. First up, we've got the metacarpal phalangeal joints. That's a mouthful, I know, so let's just call them the MCP joints. You know them as your knuckles. These are the joints connecting the bones of your palm to the first bones in your fingers. And your knuckles are what's called a condyloid synovial joint. Basically, this just means they can move in 2 different ways. They let you make a fist, that's flexion and extension, but they also let you spread your fingers apart and then bring them back together again. That's the side-to-side motion. Super useful. Now moving further down the finger, we get to the interphalangeal joints, or IP joints. If the knuckles are the base that lets your fingers spread out, these are the true hinges that give your fingers the power to curl up and grip things. And the name for this type of joint couldn't be more perfect. It's a hinge joint. I mean, just think of a door hinge. It only opens and closes, right? It only moves in one direction. That is exactly what these joints do. They only allow for flexion and extension, letting you bend and straighten your fingers with incredible control. And if you look at your 4 main fingers, your index, middle, ring, and pinky, each one of them has 2 of these awesome little hinge joints. There's one closer to the knuckle, the proximal one, and one out near the fingertip, the distal one. But what about the thumb? Well, the thumb breaks the rule. It only has one of these interphalangeal joints, and that little difference is just the beginning of what makes the thumb so incredibly special. Which brings us to the absolute game changer of the hand, the thumb. Its unique design is really the key to our ability to grasp and manipulate things, and it all comes down to one very, very special joint.
Remember those CMC joints we talked about in the palm? Well, the thumb has its own, and it is completely different from all the others. This joint, right at the base of your thumb where it meets the wrist, is the whole secret to its amazing freedom of movement.
It's called a saddle joint. Okay, to picture this, imagine a rider sitting in a saddle. One surface curves up, the other curves down, and they fit together perfectly. This unique shape allows for a huge range of motion that other joints just can't dream of matching.
And that unique shape is what leads to the magic of what we call opposition. Let's break it down. That saddle joint lets you bend and straighten your thumb. It lets you move it away from your palm and back towards it. You can even swing it around in a circle. And all of that culminates in the final incredible step, opposition. That's the ability to touch the tip of your thumb to the tips of each of your other fingers. This single movement is what defines the human grasp.
So, when you put it all together, you start to see that the hand isn't just a collection of bones and joints. It's a perfectly coordinated system. It's like a symphony of movement.
Think about it. You've got the gliding plane joints in the wrist, giving you a flexible base. You've got the mix of stable and mobile joints in the palm for strength and adaptability. You've got the precision hinge joints in the fingers for curling. And then you have that revolutionary saddle joint in the thumb that unlocks it all. Every single part plays a specific, vital role. And together, they let us do everything from wielding a hammer to performing brain surgery. So the next time you pick something up or type on a keyboard or even just wave to someone, take a second to appreciate the complex, beautiful engineering that you have right at your fingertips. This is your anatomy in action. The only question left is, what will you create with it?